Hi, a few of you may recall me coding this some 5 years ago. It was inspired by the Bees and Bombs animation, and if you were to ask me how I feel about the code now, well, I still think it's pretty okay. But there's one thing that has been bothering me ever since, and that's having to hardcode trigonometric function values into CSS custom properties. For example, we have this tangent factor, which depends on this tangent value computation, and if that wasn't enough, for each and every single component of our strip we have a cosine and a sine hardcoded as custom properties. Far from ideal, but the best we could do without trigonometric functions in CSS. Now times have changed, and starting March this year, Safari supports not just trigonometric functions, but also other mathematical functions directly in CSS, which I think is really cool. However, I haven't seen anything done with this so far. And that may be because support is limited to Safari for now, which means OS restricted. For me, being on Linux, that means testing via Epiphany, which comes with its own set of problems. So I had a lot of trouble getting it to update. I kept waiting for it to update. It just didn't happen. Weeks passed. Then I couldn't figure out how to get it to update. When I finally managed to solve that problem, it's not like the CodePen editor even works in Epiphany. However, the debug view does work, and that's what we'll be using today to test the result of rebuilding this thing from scratch using trigonometric functions directly in CSS. So we are going to have the result on one side, and on the other side we are going to have the code. So let me just... And yes, that's Tiger looking at us. So we are going to redo this because this kind of demo and demos where we have items distributed on a circle in general can really benefit from using trigonometric functions directly in CSS, but I should stop talking and get to coding. So we have our strip element. This is going to be like a wrapper. Inside it we are going to have all the component elements which are going to get generated within a loop. So we're going to have for let I going from 0 all the way up to n, the total number of components, increment I at every step, and generate a component element. Now let's put something on the screen, so make something visible on the screen. We're going to do that with a box shadow, 0 offsets, 0 blur, just this spread. Refresh. Doesn't look exciting, but it's correct because we have all those divs of height 0, which are basically collapsed. It's just one horizontal line, 0 height, right, that stretches all across their parent and has this box shadow around it with no offsets, no blur, but just that spread. Okay, so the result is correct, but not exciting. So let's move on to layout. And if you've seen my previous videos, then you know this part. We set on the HTML, on the body, and on all div elements, display grid. So like that. And we're also going to make the HTML full viewport height. So that is height 100%. Now this is going to cause that strip grid to stretch all across the viewport, minus that margin around the body, okay? But we don't want that. We want our strip to be in the very middle. So let's fix that. We're going to have strip, place self, center. The default is stretch, which you can see in action right there, right? And it looks like that. Now next step, we are actually going to set a height right here, and I actually picked those values from the previous demo, the one from 5 years ago. Okay, let's refresh a bit. Oh, I didn't save. I should remember to save before I hit refresh. Now let's bring up DevTools for a little bit because I want to show you something. So the strip grid, you can see how there is a 0 width column, but there are multiple non-zero height rows. And what we actually want, we don't want each of those components in its own row, because this is a one column grid. So every cell is on a different row, right? We don't want all those components in different cells. We want all of them stacked one on top of the other in the same cell. And that means placing them in the grid area at the intersection between the first row and first column. So basically our strip grid is also going to become a one cell grid at the intersection between the first row and first column. So here we're going to have grid area, first row, first column. And right, that looks Great. Now we are actually going to comment out that part, and we'll be left with a dot. Actually, more dots stacked one on top of the other. And we're going to want to distribute these dots on a circle. So before we get into the geometry behind this, we are going to set the total number of components as a custom property right here, so we can pass it to the CSS. And we're going to do the same for the indices of the components. Right. Okay. Now let's move on to the circle. So around the circle we have 360 degrees. We start from 3 o'clock and then we go clockwise around the circle. At 6 o'clock we have 90 degrees. At 9 o'clock we have 180 degrees. We go around the circle and we get back to 3 o'clock, which is also 360 degrees, not just 0 degrees. It's cyclic going around. So this is also going to be 450 degrees. This is also going to be 540 degrees, and so on. Okay, 630 degrees, and so on. You get the idea. Okay, now the vertices of a regular polygon are always distributed evenly around the circle. You can see it for different polygons right here. We're going to go back to the triangle because this is the simplest. Basically, those triangle vertices are splitting our circle into 3 equal arcs, right? And this is an equilateral triangle, that's why, which means that also the edges are equal, right? And those angles corresponding to those equal arcs are also equal. And since we have 360 degrees around a circle, it means that each of those equal 3 angles is going to be 360 degrees divided by 3. And for polygons with multiple edges, let's say something like n edges, that central angle, right, is going to be 360 degrees divided by the number of edges. Central angle, base angle, whatever you want to call it. Okay, I may switch between the two. It's the same thing. Okay, now let's see how we distribute those points on a circle, and let's see it for a triangle. So we distribute them at 0 times 120 degrees. So the vertex of index 0, we put it at 0 times 180 degrees, the base angle. The vertex with index 1, we put it at 1 times 120 degrees, right? 120 degrees being the base angle. And the vertex index 2, we put it at 2 times 120 degrees. Basically, every vertex is at its index times the base angle. So let's put that into code. We are going to have a base angle, which is going to be 360 degrees divided by the total number of components, right? And then we're going to have transform or rotate, and again we're going to have a calc, which is going to be I, the index of the current component, times the base angle. Now, this is not going to look like much for now, because we're just rotating them in place. And it makes sense if we are starting with all the vertices right there in the middle of the circle. Just rotating them doesn't do much. However, every element in CSS has its own coordinate system. And when we rotate the element, we also rotate its inner coordinate system. So to start with, we have that the x-axis points towards 3 o'clock, okay? But once we've rotated the element here by 120 degrees, its x-axis points that way. So it points that way. When we rotate it by 2 times 120 degrees, it points that way. So just rotating is not enough. We need to also translate after rotating, and translate by the radius of the circle, right? So we bring it from the middle of the circle to the circle itself. Now let's have a translation value, which is first going to be a random one, and then we're going to discuss how we can compute circle radius. It's a bit of a circus with me. Okay. Actually, let's just go for a random 3m's, and you can see them distributed. Let's reduce their number. Right now you can see them on the circle. And something else we could do is just give it a proper height, so uncomment that height declaration and refresh, because it's not just dots that we can distribute on a circle, it's also line segments. So for example, let's see this part right here. Line segments are the polygon edges, so we can also distribute them on a circle. Now in this case, it's this inner circle which touches the polygon right in the middle of every edge. So the circle and the polygon have only those points in the middle of the edges in common. And this is valid for regular polygons. So everything discussed here is for the particular case of regular polygons, all edges and all angles equal, okay? Now in this case, these radii, right, split the vertex angles into two, and the continuation, right, goes and is perpendicular onto the edge and splits these base angles into two equal halves. And this line, this radial line, also splits the edges into two equal halves, right? So everything, we have a lot of symmetry in the case of regular polygons, and this does not apply just for triangles. It's the same for squares, it's the same for regular pentagons, it's the same for regular hexagons. You can see there's a lot of symmetry for all these regular polygons. So in our case, what to remember, this angle between the red and the blue line is half the base angle. This is a right angle, so this here is a right triangle, right? And this is going to be half the edge, right? And this is the radius of the circle on which we want to distribute the polygon edges. Now in our case, we're going to want the polygon edges to be equal to the height of our components, right? So we're going to know half the edge because it's going to be half the component height. And again, we're going to know half the base angle because we've computed the base angle. And we can say that in this triangle, the tangent of half the base angle that we have right there is half the edge, which in our case is half the component height, over the radius of the circle that we distribute our elements on. Okay, so we have something like this. Tangent of half the base angle is half the component height over the radius that we want. So the radius is going to be half the height over tangent of half the base angle, right? So that's what we'll have right here. So it's going to be calc half the component height over the tangent of half the base angle. And note that we don't need a calc inside the tangent function. We can just have the multiplication as it is, right? So now you're going to see it better if we just font size forms. This should do it. Okay, and now let's actually give this a width as well. And it's going to start looking messy. Okay, this doesn't seem to make sense anymore. Okay, the thing is, at this point, the edges of our polygon are the vertical midlines of our components. Let's highlight those with a linear gradient. So we're going to have background, linear gradient, red, right? And it's going to be in the middle, 2 pixel thickness, and it's going to stretch all across the height, and it's going to be no repeat. Okay, and let's see, you can see the edges of our polygon. Now let's go to the first component and let's highlight it. So you can see its left edge right there, right? So that's the left edge. Actually, let's set here background color. Alice blue is going to work. Okay, you can see the left edge right there. And what if we wanted the edges of our polygon to be not the vertical midlines of our component elements, but their left edges, right? So then we need to translate our component elements by half their width, because between the left edge and the vertical midline we have half the component width. So we need to add to this translation half the width. So like this, and if we refresh, you're going to see it. Okay, so this means that we're not, actually I'm going to keep that vertical midline thing. And you can see how they seem to be overlapping a bit, and that's an illusion because the box shadow is on the outside. The actual edge forms the proper midline there. So it's not, this box shadow is on the outside of the actual element. This is why it looks like we have a slight overlap there. In reality, we don't. Okay, but what if we wanted our polygon edge to be not the component height, but twice the component height? Well, then we just multiply with 2 right here. So we have 2 times 0.5, but that's 1, so we can just get rid of it like that. And let's get rid of this as well. Let's get rid of that draft. And let's go back to the initial number of components, the number of components that we actually want. Okay, this is starting to look like something. We have items distributed on a circle. Let's move to the interesting part, where we're also going to be using trigonometric functions, other trigonometric functions, and other mathematical functions. Okay, let's make this 3D and transform rotate x 45 degrees, let's say. Now, rotating by a positive angle brings the bottom part front and up, and the top part pushes it backwards and down, right? But if we refresh this, it only looks squished vertically. It doesn't really look 3D. In 3D, what is closer to us appears bigger, and what is further away appears smaller. And we do that with the perspective property, which we set on the scene being the parent of our assembly element. And our assembly element is basically the strip, the wrapper of all the elements we want in 3D. Okay? So that's, let's say something like 35 ems. The smaller that value is, the more extreme the effect looks. So for example, at something like 5 ems, it would look pretty, yeah. But we don't want that. So, I messed it up. Okay, let's refresh. Oh, I didn't save before refresh. Sometimes it's so weird with no auto update. One thing I don't like is the fact that it's closer to the bottom than to the top. So we're going to add a vertical translation. So translate y by minus half the component width. Okay, and let's also set a perspective origin that is a bit higher up. So perspective origin in the middle horizontally, but vertically is going to be 50% minus component width, let's say. Oh, yeah, that's why. Okay, I think we could have done a bit more, a teeny tiny bit more. We're not going to waste time on just tweaking that. Okay, let's make things a bit more interesting by adding another rotation, a rotate y, basically a rotation around that vertical midline. And now here, in the plane of their parent, these components are rotated by an angle that goes from 0 to 360 degrees, right? We're going to want to rotate around their vertical midline by an angle that goes from 0 to 180 degrees. Basically half this angle, which we're going to call it a current angle. So we're going to have a current angle set right there. So here we're going to have rotate Y, half the current angle. And okay, that's what I messed up. I cannot use the keyboard. Okay, this looks dubious. And it looks dubious because these component elements get flattened in the plane of their strip parent. This happens because we don't tell the browser that we want to have 3D transformed elements inside other 3D transformed elements. We're also going to want these components to have two faces, a front and a back, and those are going to be pseudo elements that also get transformed in 3D. So we are going to set on all div elements transform style preserve 3D, so that we can have 3D transformed children inside 3D transformed parents. And now you're going to see how this actually looks 3D. Okay, much nicer. And I said something about pseudo elements. Let's do that. So we're going to have before and after. And actually these pseudo elements are also going to be stacked one on top of the other, covering the entire component grid cell. So the component is going to be a one cell grid, and these pseudo elements are going to be stacked one on top of the other, covering the entire cell grid cell. Words are so complicated. Not my strong point, definitely. So we're going to have grid area, that grid area declaration. We're going to have it for both divs and pseudo elements. Okay, and we're going to bring those dimensions right here. We're going to have content because otherwise nothing's going to show up. And we're also going to have a flag, if you want to call it, or a switch, whatever you want to call it. It doesn't really matter what you call it. Just call it. Give it a call. And it's initially 0, but then on the after, we switch it to 1. Okay? And we're going to make the background depend on this. So, for example, we're going to have HSL and a calc, let's say, J times 180. It's not going to stay like that. Maxed out saturation, midway lightness. None of those three values is going to stay like that, but we'll take care of that later. And here we are going to have a rotation around the y-axis, around that vertical midline, right, by 180 degrees, or half a turn. So half a turn. And by the way, 360 degrees, maybe one turn, it's the exact same thing. It doesn't matter how you write it, right? It's the exact same thing. So let's refresh that, and it looks really weird. And it looks weird because we haven't set a backface visibility hidden. So what this does, if we look at an element from the front, we see it. If we look at it from the back, it's invisible to us. Okay, so in our case, we are going to set here backface visibility hidden. So we don't see the back face of our pseudo elements because those back faces are back to back anyway. However we rotate our component, we either see the front of the before or the front of the after. We don't see the back of either of those. Okay, so backface visibility hidden. Okay, let's do this, and it looks a lot more interesting. Now, one thing I want to show you. Here we have the transition from one color to the other right here at 180 degrees or 9 o'clock. That's where we go to zero saturation, to fully gray. So zero saturation means fully gray. Let me just show you right here. Let's explode this HSL bicone. So you can see we have the hue all around. The lightness goes from black at the bottom to white at the top. And in the middle, we have pure gray. And the gray may be lighter or darker. So fully dark, zero lightness gray is black, right? 100% or one lightness gray is white at the top. And you can see in the middle, it's always gray. So the saturation goes from 0% in the middle, where we have pure gray, lighter or darker depending on where it is on the lightness scale, so that's 0% saturation, to 100% saturation on the surface of this bicone. Okay, so this saturation we want it to be 0 at 180 degrees, 1 or 100, whatever you want to represent that as, at 0 degrees, 360 degrees. Okay, now that sounds like something like this cosine function in orange right here, which goes from 1 at 0 degrees to -1 at 180 degrees to +1 again at 360 degrees. So basically we want our saturation to go from 1 right here at 3 o'clock, 0 degrees, to 0 here at 180 degrees, and back to 1 here at 360 degrees. Now, the cosine doesn't go to 0, it goes to -1. But if we were to add 1, here we add 1 to 1 and we get 2. Here we add 1 to -1 and we get 0. And here we add 1 to 1 and again we get 2. Okay, but now we're going from 2 to 0. Again, not what we wanted. But if we divide this sum by 2, then here 1 plus 1 divided by 2 gives us 1. Here 1 minus 1 gives us 0, divided by 2 gives us 0. And here 1 plus 1 divided by 2 again gives us 1. So that's what we'll do for saturation. Right? We are going to have calc, and here we are going to have 1 plus cosine of the current angle multiplied, first divided by 2 and then multiplied with 100%. But divided by 2 multiplied with 100% is multiplied with 50%, right? So let's see it. Right, we go to fully gray right there. Let's get rid of those. We're not going to need those outlines anymore, right? So we go to fully gray right there. Okay, but what we actually want is to have this first half one color and this other half another color. So for both the before and the after, we want one color here, right? So for the before, we want, let's say, red here and blue here, and for the after, we want blue here and red here. So we don't want this hue to depend on just the face, whether it's the before or the after. We also want it to depend on the half. So we are going to compute a sign, which is going to be -1 for the first half and 1 for the second half. And we are going to start by computing a middle index. Now the middle index is the average between the first index, 0, and the last index, n-1, sorry. And the last index, which is n-1. So 0 plus n-1 divided by 2 to get the average, right? So to get the average, we sum them up and divide by 2. Now 0 added to anything is like that. And this is like we multiply with 0.5. So this is going to be calc 0.5 times n-1. Now our current indices I are going to be smaller than M before the middle at 180 degrees, 9 o'clock, and bigger than M right here. So the sign of the current index minus M is going to be -1 here and 1 here. So let's get that sign. And the cool thing is, now we actually have a sign function in CSS, not just trigonometric functions. So we can have I minus M. Note how we don't need to use calc here either. So inside the sign we can have the operations and it's just fine. Now here we're also going to compute a sign for J, and this one is going to be J minus the middle between 0 and 1. So sign J is going to be sign of J minus 0.5, the middle between 0 and 1. And then we're going to compute sign, which is going to be calc sign of I times sign of J. Because if we were to use just the sign of I right here, then the hue wouldn't depend on the face. It wouldn't depend on whether we are setting it on the after or on the before. So we want to make it depend on the J as well. So here we're going to have sign, if I can write that correctly, times 90 degrees. So let's see it. And you can see how we always see the same color. And if we were to add half a turn here, we're going to get the opposite. Okay, let's get rid of that. And we want to get the colors. So something like that. Okay, we have our blue. And to see the red on the other side, we are going to add in the animation. And it's going to be the exact same animation we had last time in this demo from 5 years ago. As I said, I think the code is still pretty okay. So, and the animation is not really important. So, yeah, I'm just going to have that position notation. So, right here, we're going to use this position notation, right? And transform is going to be that position, and rotate Y at first it's going to be 0 degrees, right? And then we're going to have the animation, and yeah, again we can just copy paste that. We're just going to, and that K value, I haven't explicitly computed it here, but it's basically the progress. It's I over N. So that's the K progress. So let's see it. All right. Okay. It looks really nice, but the fan is going crazy, so we're going to just remove the animation for now. Something else we're going to want is, I want to show you right here. You can see how one side is darker here and lighter on the other side, and pretty much the same here. So this means the lightness going up and down. So for one side is going to go up, then it's going to go to the middle, then it's going to go down, then it's going to go to the middle again. That looks like something. It looks like the sine function, which goes to 1 at 90 degrees, and then it goes to a 0. So this is basically the midline of the sine, and then it goes to -1. Now, we don't want the lightness to go in the negative area, because lightness in the negative area doesn't mean anything. Anything below 0 is still 0. But we can move this sine graph up by 1. So basically add 1 and then divide by 2 to limit the values in between the 0, 1 interval, right? So exactly like we did for the cosine. So we are going to do something very, very similar right here, right? Except we're going to have sine. So let's refresh right here, and if we add back the animation, you are going to see it in action. But we don't want to here, when the sine is 1, we add 1, right, and multiply it with 50%. To multiply with 50% gives us 100%. That is basically full white. We don't want to go up to there, so we are going to add not 1, but half of it. And when the sine is -1, then we're just going to subtract 0.5. We're not going to go to 1 minus 1, which is lightness 0, which is fully black. So we're not going to go all the way to black and white. Okay, but you can see how it's light on both sides, and we want this to depend on the side. So we are going to have that sign there as well. So if we refresh, you are going to see how it's dark on one side and light on the other side. Now for the saturation, we don't want to go all the way up to 100% saturation. Let's say we only go up to 86%. So if the cosine is 1, then we have 1 plus 1, 2, times 43, that's going to be 86. So yeah, that's a lot nicer. So I'm just going to leave it at this. I'm not going to tweak it any further because it's quite resource intensive for a 16-year-old laptop. But I do hope you've enjoyed this video, and if you have and you like the work that I'm putting out for more than 10 years now and you want me to be able to do more in the future, please consider supporting it. You can do so by being a cool cat and becoming a patron on Patreon, or if monthly support is not your style, there's the option of a one-time donation. There's also the option of a weekly anonymous donation. That's going to be linked as well. Or you could at least make this stray cat happy by getting her something off her wish list. Or you could at least share this to show the world what can be done with CSS these days, because honestly, I think it's pretty damn cool. In any event, thanks for watching, and I'll see you next time, when my laptop doesn't overheat and I can record something. Bye!